Welcome Algebra 1 students to your video on quadratic functions and finding zeros. We're going to listen to Paul Simon today, the album called Graceland, one of my favorite albums of all time. It definitely makes me old that it's one of my favorite albums of all time, and hopefully you enjoy at least some of the music. Anyway, we're going to be talking about parabolas. See this word right here? Parabola, not parabola, parabola. Make sure that you're accenting the right syllable of the word. And so we got a cute little parabola kitten. And we have the basic parabola. This one's sideways. I just liked this image because it had some of the parts that we don't even talk about. We'll talk about vertex. We'll talk about axis of symmetry. We won't talk about focus or directrix, but the focus and the directrix, their location affects how wide the parabola is and how stretched out it is. Just something cool I thought I'd show you. Let's start with definitions. Okay, a quadratic function is a function that can be written in this form. Y equals ax squared plus bx plus c. Now that already looks familiar. That's what we've been working with already. So a can't be 0 because you have to have an x squared in your quadratic function. And what you have is the standard form of the quadratic function, and that's what we're going to be working from. Okay, sorry I had an interruption. Resuming now. Okay, so standard form of quadratic function is when you have it in standard form, this right-hand side in standard form. So you could have y equals 3x squared, you could have y equals 3x squared plus 9, you could have y equals x squared minus x minus 2. You could have any variety of that. Just a, b, and c are going to be real numbers. And in most of the examples we look at, a, b, and c right here will be integers, not just real numbers. So no decimals or fractions. Okay. The graph of a quadratic function is the U-shaped curve called a parabola. So this is a parabola. Okay, it's going to keep on growing outward in both directions forever. Okay, it's a U-shaped graph. It's got a vertex. That's either the highest or the lowest point. And it's got an axis of symmetry. So let's point out a couple of these things here. This would be your vertex right here. And your axis of symmetry for this one would be the line where x equals 0. So this would be your axis of symmetry. Okay, and divides that parabola into matching halves. It's that foldable line that you used when you were making butterflies in kindergarten in art class. You'd fold it over and make a pretty reflection of the wing on the other side, and yay, butterfly. Okay? The vertex is either a maximum or a minimum. If a, the leading coefficient, a right here, if a is positive, the parabola opens upward, and the vertex is a minimum, like the example we saw on the previous page. Here's a parabola with a minimum. If a, however, is negative, the parabola opens downward, and the vertex is a maximum point. So that would be as if I have a sad parabola, in which case this is a maximum point. So when you have a sad parabola, you got a maximum, and when you have a happy parabola, that's this guy over here, okay? To make it a little bit clearer, let's just give them a little bit of character. Sad parabola. Actually, he looks kind of mad. Let's make him sad. There we go. And this one's happy. Happy parabola minimum, sad parabola maximum. Again, what do I know about the equation that helps me see that? The a value, the coefficient of the quadratic term. If it's positive, it's a happy parabola. If it's negative, it's a sad parabola. Okay, let's graph the function y equals x squared. Now, we're not going to graph a whole lot of these by hand. We will do some more by hand graphing in class. But because we don't have the idea of what these graphs are going to look like yet, I want you to start by making a table. And our x values are going to be, we're going to keep them symmetrical around 0 for right now for this one. -3, -2, -1, 0, 1, 2, and 3. All right, go through and plug in those x values. What do you get for y? -3 squared, remember, is positive 9. Remember, that's -3, the quantity squared. -2 squared, positive 4. -1 squared, positive 1. 0 squared, 0. 1 squared, 1. 2 squared, 4. 3 squared, 9. All right, so we're going to graph those ordered pairs. So -3. So from the origin, go to -3 and then up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Uh-oh. 1, 2, 3, 4, 5, 6, 7, 8, 9. When you switch tools, you have to look away so you can switch tools, and then where was it? All right, next one is -2, 4. So, -2, 4. Oh, Anybody notice what I did? Uh-oh, I can't erase it. Oh, poopy. Oh, well. We'll put it here. Not that one. Okay. All right. Negative 1, 1. 0, 0. 1, 1. 2, 4. Are you noticing anything yet? And 3, 9. Look at the symmetry. Look at the symmetry on either side. So you have your vertex right here at 0, 0. And you got a point 1, 1. And then you got the same point across that axis of symmetry. Here's 2, 4. Same point over here. Almost like a reflection. Remember to ignore the one I X'd out because it won't let me erase once I've switched tools. Okay. And there's our parabola. Try to make it curved. It's not a V-shaped graph. It's a quadratic graph. And that quadratic graph is U-shaped. So there's no straight lines here. It is a curve. No straight lines. All right, let's look at graphing by transformation. Okay, so we went ahead and graphed that first one, and I went ahead again and graphed it in black. So I'm just going to underline that one so you know which one it is. Now that we got 3 others that we're going to graph, and it's 3 basic transformations. So we're going to do a little graphing by transformation, and when you're in class, we'll learn how to graph them by hand when they're more complicated. But let's look at what happens with this first one. So the second one, really, because it's the second one on the list. Y equals x squared minus 4. What do you think the minus 4 does? Logically, that minus 4 should be some sort of translation, and it should either go right and left or up and down. In this case, it's a vertical transformation. It goes down 4. I can make the table of values for that one. I'm going to make it nice and small here so I can fit the other ones and the other colors. If I put in, let's put in 0, and we'll do negative 1 and negative 2 for each. 1 and 2. So negative 2, negative 1, 0, 1, and 2. So if I plug in negative 2 squared is 4, minus 4 is 0. Negative 1 squared is 1, minus 4 is negative 3. 0 squared is 0, minus 4 is negative 4. You see what I'm doing, right? I'm just plugging in the x right here. 1 squared is 1, minus 4 is negative 3. Oh, well there's that symmetry again. You see that there? That it matches? I bet you this last one is a 0. 2 squared is 4, minus 4 is, yep, it is indeed 0. So negative 2, 0. Negative 1, negative 3. 0, negative 4. 1, negative 3. 2, 0. And there's our shape for our parabola. Now, I'm not going to extend it up too far because I don't want to start putting it in the wrong place. But you can see that this ended up being a vertical translation, that it translated the whole parabola down 4. Okay, let's do the next one. Y equals 2x squared. So again, let's make our little table of values. If I plug in negative 2, negative 1, 0, 1, and 2. All right, negative 2 squared is 4 times 2 is 8. So negative 2 is going to be all the way up at 8. So I think I know what this one's going to do. I think it's going to make it taller. Sorry, I'm struggling to write this tiny little 8. It's very hard to write very small with a stylus. Let me get a smaller stylus and see if it helps. No, that's better. Negative 1 squared is 1 times 2 is 2. 0 squared is 0 times 2 is 0. Oh, look, the vertex is still going to be the same as the original, so that's interesting. 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. So let's graph the green one, a blue one. It's not green, it's blue. All right, 0, 0. Negative 1, 2. Negative 2, 8. 3, 4. There we go. And the same thing on the other side. 2, 8. And 1, 2. It's skinnier. It's a skinnier parabola. So what happened is it's what's called a vertical stretch. It's a stretch. Oops, sorry guys. Stretch. So it doubles the y value. It stretches it out longer. It's called a vertical stretch. All right, last one. So this one on the original was y equals, it should have been negative x squared, and I made a typo. So let's go ahead and do this one in green. Okay. So that negative happens after you do the squared part. So let's use the same x values. Negative 2 squared is 4, and then you tack the negative on and you get negative 4. So this is the first time I'm getting a negative y value for this one. Let's see what keeps happening here. So negative 1 squared is 1, tack the negative on, negative 1. 0 squared is 0, negative doesn't matter. 1 squared is 1, tack on the negative. 2 squared is 4, tack on the negative. So we got 0, 0, we got negative 1, and 1, negative 1. And we got negative 2, negative 4, and 2, negative 4. what did that minus sign do to the original black parabola, that original x squared parabola? It's a reflection. It's a reflection over the y-axis. So we just did some graphing by transformation. Now, if you were using the calculator, if you're using your TI-84 calculator, you're going to use the table quite a bit. And most of the graphing that we do in class, we're going to do with the calculator because it's kind of silly to do a lot of graphing by hand. I just need you getting a feel for what the graphing looks like and what it feels like when you're doing it on paper once or twice. So we'll do a little bit, but most of the graphing we do in class will be on the calculator. Moving on. Zeros. The x-intercepts of a function are also known as the zeros of the function. They're the x values for the points where y equals 0. So what we're talking about here is any function at all. So I'm going to do 3 different ones here. All right, so a line. So this one has a 0 there. A parabola has 2 zeros. We could do an absolute value graph, which can have 2 zeros. There and right there. Okay, so the zeros are the x-intercepts. It's where whatever the function is crosses the x-axis. Let's go ahead and find the zeros of each of these functions. So I need an x and a y-axis first. Okay, I know you're probably thinking, what is Miss LeCompte listening to? Paul Simon, it's old, but it's really good music, I think. So when I come back, it'll be on a different song. Let me go ahead and set up the graph. All right. So now we have 3 different functions we're going to graph. And we're going to be looking at the zeros of these functions. So let's start with the blue one. The blue one is a linear function, just a plain old line. I went ahead and gave you a table of ordered pairs that you can use if you want. But let's just graph it the way we know how. Y-intercept to 8. 1, 2, 3, 4, 5, 6, 7. Oh, that's why. I can't fit the y-intercept to 8 on there. That's okay. We'll just go through and fill in the table. -2 times -2 is 4, plus 8 is 12. Not going to be able to fit that on my graph. 0 times -2 is 0, plus 8 is 8. -2 times 2 is -4, plus 8 is 4. -2 times 4 is -8, plus 8 is 0. And 8 times -2, -16, plus 8 is -16 plus 8, -8. Goodness, that doesn't seem right. That's probably right. All right, let's plot what we can. We can't plot -2, 12 or 0, 8 because we can't fit them. But 2, 4, I can plot that. 2, 4, right here. Okay. 4, 0. And 8, -8. So, oh, why did I skip 6? Let's make that a 6 instead. So -2 times 6, -12, plus 8, -4. Make it negative, so make it 6, -4. So 6, -4. And there's our line. Okay. And the 0 for this is where it crosses the x-axis. So what's that x-intercept right there? Okay, let's take a different color and let's circle it. Right there in yellow. Okay, so the 0 for the first one, the 0 is 4, because that's where it crosses the x-axis. All right, next one is in red. So the next one, we're filling the table. Now, if you go back to your previous part of your notes, you've already got this. This would be 0, this would be -3, this would be -4, -3, and 0 again. So let's plot those. Let's graph this. So -2, 0, -1, -3, 0, -4, 1, -3, and 2, 0, and we've got our parabola. And this parabola has 2 zeros. So where does this cross the x-axis? Well, there at 2 and there at -2. So the zeros for this second one, the zeros, there are 2 this time. The zeros are +2 and -2. Now the green one. Now the green one, we can't graph the way that we're used to. So I'm going to go ahead and walk you through graphing this. So if we plug in these numbers here for this function, we're going to have -6 squared, 36, -24 is 12, -12 is 0. So at -6, we're going to have 0. -2 squared is 4, plus 8 times -2, -8. 4 -8 is -4. -4 minus 12 is -16. Well, that's not even going to fit on my graph. So I'll probably have to improvise when I get there. 0 squared plus 4 times 0. So 0 plus 0 minus 12, negative 12. That is also not going to fit on my graph. 2 squared is 4, plus 2 times 4, which is 8. 4 plus 8 is 12, minus 12, 0. Okay, so negative 6, 0 is right there. Negative 2, negative 16 is so far down below. It's way down here. Way down here. We can't even see that part of the graph, so we're not going to be able to graph that. I can't graph 0, negative 12 either, so I might have to figure out some other points here. And then I have 2, 0, which is actually the same 0 as this other one. Now I know it's a parabola, and I know that the vertex is way, way, way down there. So in order to graph this, I'm going to sort of simulate that it's a parabola. So it's going all the way down and disappearing, and then it's coming back up and coming through that side. And so you've got your shape of your parabola, right? Well, you've also got your zeros. So when we're looking at zeros in class, you might be doing so right from a graph, or you might be doing so from the calculator screen as well. So what are the zeros for this last one? The zeros were negative 6 and 2. So again, zeros, same thing as x-intercepts. Perfect chance to stop the music for now. And that's it for tonight's video. I know that this was kind of a whirlwind, and this is our last new material before the benchmarks. So hey, there's that. And I will see you guys in class.